Hey everyone, welcome back to another Kubernetes tutorial. In this video, we are going to get hands-on with Kubernetes services using Minikube running on Rocky Linux 9.2. We will walk you through all four major service types: ClusterIP, nodeport, load balancer, external name. If you haven't seen my earlier video on Kubernetes networking and how service works in theory, I highly recommend watching that first. You will find a link in the description and also I will add it in the card above. So let's get started. So just a quick note, I am using a Rocky Linux 9.2 as a host OS, Docker as a Minikube driver, Minikube to simulate a Kubernetes cluster locally. Make sure your Minikube cluster is running. Minikube starts with this command, Minikube start followed by driver equals to docker. This is the command to start a Minikube, and to check the status you can run Minikube status. So now let's create a simple deployment. Run kubectl, create deployment, my-nginx, provide the image. Deployment is created. Now expose it. Deployment my-nginx --port equals to 80. Port is been exposed. This creates a ClusterIP service which is the default in Kubernetes. You can test it from inside the cluster using a test pod. I will run kubectl run test pod --image, give busybox as an image, it, and I will set restart equals to never and provide the shell. So once you are inside the shell, let's run wget command -q capital O -http my-nginx. So here you can see the welcome page. This is the expected output. This confirms that our Nginx deployment and a ClusterIP service are working. Since ClusterIP is only accessible within the cluster, we had to use a test pod to curl the service. This is typical for backend services or internal APIs. So now let's expose it using the nodeport type to access it from the host. Exit from the pod, kubectl expose deployment nginx, give the port 80, type will be nodeport, name equals to nginx-nodeport. Sometimes you may get an error saying that it's already exists. You can just delete it and recreate it. Now check the service. Kubectl get svc nodeport. Then get the external access URL. Minikube service nginx -nodeport. Typo. This is the URL. You can open this URL in your browser. You should see the Nginx welcome page. So if you are using mobile extern, then just run Minikube service nginx-nodeport and remove this --URL. So here you can see a graphical application has just failed to start because your X server is not currently running. Do you want to start it? I will say OK. This command will automatically try to open the service in your Windows browser using MobiXterm X server integration. If the browser does not launch, you might see the error. Let's rerun once again. Check the X server. If you get any error, no worries, just rerun the command Minikube Service nginx-nodeport as shown on my screen. You can see it usually work on the second try, and you can see I have received a welcome Nginx page. What if in case if it automatically not open? Go to the terminal. If automatic opening does not work, you can still get the URL manually by running -URL. Copy the link and open it manually in your Windows browser. Either way, you should see the Nginx welcome page served via Kubernetes Nodeport service. So now let's define a service using a YAML file. This is how the services are usually managed in real-world Kubernetes setup. So let's create the file nginx service.yaml. So here we will define everything. API version, kind will be service, and metadata name, nginx service-yaml, specification, provide the type, node port, N capital and P capital, selector, app, my-nginx, ports, here only ports, mention port number, target port 80. Let's save it and apply kubectl apply -f. v1 cannot be handled. Something okay, we are able to apply this YAML file kubectl svc nginx service YAML minikube service nginx so you get the URL. So this will open the page. Let me close everything and rerun once again. This does the same thing as before, but using declarative YAML, which is the great for version control and team collaboration. You can see I have already closed that window. After running this command, we are able to see welcome to Nginx page. So next, now let's simulate a load balancer service using a Minikube. In a real cloud environment like AWS or GCP, Kubernetes automatically provision an external load balancer and assign an external IP. But since we are running Minikube locally, we will simulate this using a built-in tunnel. So let's expose the deployment with load balancer type. Deployment my-nginx type equals to load balancer. Provide the port, give the name equals to nginx-lb. Okay. Make sure to include -- port equals to 80 flag, otherwise you will get an error saying the Kubernetes could not find the port. Now let's start the Minikube tunnel in a separate terminal. Duplicate tab. Let me zoom it. Here I will run Minikube tunnel. This command sets up a virtual network tunnel from your host machine to a Minikube cluster, allowing load balancer service to function even on your local setup. You may ask for sudo access, that is expected. Provide the password. This tunnel simulates a cloud load balancer, adds a route to a Minikube IP, allows external access to a service with a type load balancer. So now return to our original terminal and check the service. kubectl get svc. We have given nginx-lb as a name. You will see something like this. So if you see external IP starting with 10.x, that's an internal and won't work directly in your browser unless you will use a tunnel or port forwarding. So instead of opening that manually, just run Minikube service nginx-lb. Let me close this. Rerun the command once again. You will get a pop-up for X server. If you are using a mobile extern, this will automatically launch your default browser via X server integration, and you will see the Nginx welcome page. Cannot display. Let me rerun once again. Now you can see the Nginx welcome page. It's loading now. Yeah, that's it. Welcome to Nginx. This works beautifully when you are using a mobile extern to access your Rocky Linux VM. It handles X11 forwarding and GUI apps right from your terminal. And this works smoothly thanks to mobile extern X11 forwarding. Let's understand how to use external name service in Kubernetes, which lets you to map a service name to an external domain like public API or a website. Think of it like a DNS alias ext- example-service example.com. Think of it like a DNS alias. When any pod access ext example-service, Kubernetes redirect it to a example.com. So let's create a file name first. I will create external name .yaml API version equals to v1, kind will be service, metadata, provide the name. I will give ext hyphen example service, provide the specification, external name it will be example.com. Let's apply this kubectl. So let me explain this first. Any pod that tries to access ext-example-service should be redirected to example.com. So now let's apply kubectl apply -f external name. This should apply instantly. No pod will be created, just a DNS alias or a mapping inside the cluster. So run a test pod kubectl run test client. I will use image as a busybox -it restart to never, provide the shell. Once you are inside the shell, we will run or we will ping to the est-example-service, or let's wget -q capital O -http ext-example-service. So you received a bad request. That's perfectly fine. This means your request did reach example.com, but the site did not like the format used by the busybox wget. So your service is working. Let's verify. nslookup ext-example-service. So here you can see, if you see the output like this, here when you ping to, when you are checking nslookup to ext-example-service, you will receive example.com. That means Kubernetes DNS has successfully mapped your service to example.com. This demo shows how Kubernetes external name service work. No internal pods are involved. Kubernetes just acts like a smart DNS. Works great when you want to abstract external APIs or service behind the internal names. Exit this. And the next is, we are skipping the network policies in this demo since it's an advanced topic and requires a CNI plugin like Calico. Don't worry, we will cover this in advanced tutorial. And that's it. You have seen all the 4 types of Kubernetes service in action using Minikube on Rocky Linux 9.2. We have covered internal only traffic using ClusterIP, host accessible service using nodeport, simulate public IP via load balancer, internal DNS name pointing to our external website using an external name, plus we used YAML for real world service definition. If this demo helped, don't forget to like, subscribe and hit the bell icon for more Linux and Kubernetes tutorial. See you in the next one and thanks for watching.